area as well, not today but eventually in the chapter. And so first of all we need to define what a polyhedron is. And yesterday you went ahead and created polyhedrons using the toothpicks and the marshmallows. And so let's go ahead and revisit what we learned yesterday. A polyhedron is a solid formed by polygons that enclose a single region of space. Okay? And a little bit about polyhedrons is, you notice you have your faces, which are your flat polygonal surfaces of a polyhedron. So your faces, they were created with the edges, which is a segment where two faces intersect. These were the toothpicks. Okay? And the vertex, the vertices were the marshmallows. And so yesterday when you did your activity, you found the relationship between the faces, edges, and the vertices. Okay, and you came up with a formula for that. And so let's go ahead and look real quick. And so yesterday you created a tetrahedron, which is a polygon with 4 faces. Now a tetrahedron is a little bit odd because everything else is classified by their number of faces. But a tetrahedron isn't. I mean, that's just a 4-faced figure, polygon, is called a tetrahedron. The other ones are all based on the number of faces they have. And so some of you were asking me, like that 8-sided figure, what's it called? Well, that's called an octahedron. Okay, 6-sided figure is a hexahedron. 7-sided figure is a heptahedron. Decahedron, how many faces will that have? 10. So that's all what it's based on. So if you're wondering what to name it, count how many faces it has, and then that'll be the name. So a prism, and we talked about this yesterday, and a prism is a special type of polyhedron with 2 faces that are called bases that are congruent parallel polygons. So a prism has to have a top and a bottom that are the exact same. And then in a prism, we have what are known as the lateral faces. The lateral faces are the faces that are around, that are on the perimeter of the bases. That's what the lateral faces are called. And then you have your lateral edges, which are where the lateral faces meet. And so in thinking about that, if you look at this diagram here that talks about a hexagonal prism, you have your 2 bases. And then you can see how the lateral faces are, and then you can see where the lateral edges are. So basically the lateral edges in this figure are going to be vertical, and the lateral faces are going to be vertical as well. So, questions about what a prism is? Any questions about what how prisms are classified there? Notice you have a rectangular prism, triangular prism, hexagonal prism. It's basically a prism is named by its base. So if its base was a pentagon, it'd be a pentagonal prism. Okay. So far so good? Okay. So we're going to go ahead and then look at the next slide. Okay. And we're going to talk about right prisms. Now basically, okay, I don't know if you'll necessarily need to write this down about a right prism. You might be able to condense it a little bit, but it's a prism whose lateral faces are rectangles and whose lateral edges are perpendicular to the bases. So a right prism is up and down, okay? The lateral faces have to be rectangles. So an oblique prism is not a right prism. So when I think about an oblique prism, I think about one that slants. And the best way to look at that is to look at an example. And so if you look at those examples at the bottom, you can see the difference between a right prism and an oblique prism. An oblique prism, to me, is slanted. That's the best way to think about it. It's not upright. Whereas a right prism is upright. And then an altitude. I don't know if necessarily you need to write down the definition of the altitude because it is pretty standard in terms of the altitude that we've already learned. The altitude is just the height of the prism. Okay, the definition in the book was any perpendicular segment from one base to the plane of the other base, also known as the height of the prism. Okay. So anyway, like I said, that altitude carries through, so I don't know if that's necessarily one that you need to write down because you're probably going to remember that anyway. The biggest thing, though, that you need to get down is that the right prism is upright, the oblique prism is slanted. Okay. So the right prism is upright, the oblique prism is slanted. So let's go and talk about a pyramid. A pyramid, basically what you could say is you could say it's a polyhedron with one base. Okay? You could abbreviate that real quick. Polyhedron with one base. Notice we named the pyramid on the shape of the base. So that first one is a trapezoidal pyramid, a hexagonal pyramid, and a square pyramid, based on what shape the base is. Okay, notice you have your vertex, your lateral edge, your lateral faces. Those are all similar to what we've looked at. The vertex is just going to be the tip. And then cylinders. Okay, I don't know, you probably should already know the definition of a cylinder. I mean, it's one solid with a curved surface. I mean, I don't know if you need to write that down because we've looked at that with a pop can. An axis is the segment connecting the centers of the bases. You might want to write that one down. Okay, it's the segment connecting the centers of the bases. You know what the radius is? It's the radius of the base. A right cylinder, the axis is perpendicular to the bases, and an oblique cylinder is a cylinder that is not a right cylinder. So basically, once again, a right cylinder, I don't know if you would need to write this down, but a right cylinder is upright. What about an oblique cylinder? What's that? Slanted. So when we refer to something as being a right object, it's upright. Okay, it doesn't have any bends. When we think about an oblique, we think about something like the Leaning Tower of Pisa. It's going to lean a little bit. It's not going to be straight up and down. Okay, so far so good? Okay, looks like we've got one more slide to cover before I let you go. And this is just about figures. And we can talk and do some definitions with codes in that. Your book has some definitions. But based on what we've already learned, I don't think it's necessary to define. What's a right cone going to be? One that's upright. What's an oblique cone going to be? One that's slanted. Okay. So what's a sphere? We have a sphere here. There is one thing on the sphere that we haven't maybe learned about. What do you notice there that we haven't maybe talked about? The great circle. The great circle is this right here. Yeah, it's the longest circle. We call it the great circle. Yep. It's the largest circumference. Goes through the middle. So like right here, here's where your great circle would be. Okay? The great circle is used to find the radius, used to find the diameter. Okay. So, today what I need you to do for me for Monday, 1 through 22 on page 524, 525. Like I said, it's not going to take you a long time to go through there. Okay? It's just going to be identifying shapes, saying what they are. Okay? And that will be due Monday.